Hello everyone. In our last class, we talked about Venn diagram, we talked about operations on a set. There was quite a lot of content in our last class. First, let us quickly revise. When we talk about A union B, what is that? A union B, the terminology will be the elements that are present in either A or B, the elements that are present in at least one of the set. That is union. So in this, what we do is we write all the elements of A as well as add on all the elements of B. Agree? Then we had intersection. A intersection. In union, it was the entire circle. Intersection stands for and. Union stands for or. So this is and what do we write in intersection? We write the common element, the element that are present both in A as well as in B. Then we had A minus B. A minus B was only A, that is A but not B. I want A but I don't want B. So A minus B. This agree? Huh. So A minus B can also be written as A minus A intersection B. Same goes with B minus A. So B minus A means only B. I want B, but I don't want A. Agree? So from B, just remove the common area that it shares with A. Then we had symmetric difference. What was this? Set of all the elements that belong to exactly one set. Right? Set of all the elements that belong to exactly one set. Either it belongs only in A, that is A minus B, or it belongs only in B, that is B minus A. So I want A minus B or B minus A. And for or, what symbol do we use? So it is this union. Or what we can do is, see, asymmetric difference B is both the sides. So from the union, we can also subtract the intersection part. That will also work. Yes or no? Then we had A complement. That was not A. Something that does not belong to A. It has no connection with B. That is universal set minus the set A. If this is A, the outside region is A complement. So whenever I want to find the complement of any set, I'll subtract that set from the universal set. For example, if I want A union B whole complement, what will I want? I'll subtract universal set from A union B. I want A intersection B complement. What will I do? I'll subtract a universals from the universal set. I'll subtract A intersection B, right? So no matter which set's complement I want to find, I'll subtract that set from the universal set. Agree? Online clear?
Yes, ma'am. Yes, ma'am.
Now, there are a lot of properties here. Okay, there are a lot of smaller things here. So we'll today first start with the detailing of all those things. Okay. Then we'll move on to the word problems again. So no, again, properties or something, any which way we can talk about. First, first, if I write union, whether I write A union B or we write B union A, it doesn't matter. I just want to write both the sets. So when I'm drawing, whether I start the shading from left side or I start the shading from right side, doesn't matter. I need to take both the sets. So union of two set is commutative. The word commutative, no matter where you are studying, is always same. Commutative says rather than this, we can do this. Change the order. We are sitting in this position, so it won't matter. That is commutative. A into B, B into A minus B, B minus A union B, B union A. 2 plus 3, 3 plus 2. So if it doesn't matter, it's commutative. If it matters, it's not commutative. Yes? Similarly, can you tell me for intersection, what will you have? What will happen? Intersection. Again, it is commutative. Yes, it won't matter. What about difference A minus B and B minus A? That's not commutative. It matters whether we are writing A minus B or we are writing B minus A. Agree? Then we have associative. Associative says bracket. 2 plus 3 plus 4. Whether I do 2 plus 3 and then add 4, or I do 3 plus 4 and then add 2. I'm not changing the position. I'm just changing the bracket, which means first I'll calculate A union B, and to its answer, I'm going to find the union C. Or whether I calculate B union C first and then combine A with it. It means the same thing. Rather, when you're finding union, you can find the union of all the three together itself. 1, 2, then you have 3, 4, then you have 5. 1, 2, 3, 4, 5 is the union straight away. Same goes with intersection. What is intersection? That is common between all the three, right? So this will be A intersection, B intersection, C. Associative property says only these two things, the change of bracket, right? Again, it won't matter. It won't be applicable in the difference part, right? What about symmetric difference? Is it commutative? Is symmetric difference commutative? In both the cases, I need to take both the sides. So yes. Okay. Now comes distributive property. Distributive property is a combination of two operations. Like when you earlier had in algebra, x into a plus b. And I open the bracket. Here there are two operations, multiplication outside and addition inside. So if I open the bracket, what will I get? Ax plus bx or x a plus b, whatever it is, xb. Yes. So this x multiplied goes with a, x multiplied goes with b, and then we have an addition sign in between. The same thing is applicable in sets between union and intersection. Okay. And majority of them I won't use in some, almost none. It's just theory for assertion reasoning, for MCQs. You just need to know this. It's not required for the larger sets. Okay. So A union B intersection C. So open the bracket. So A union will be given to B. A union will be given to C. And in between, what is the symbol I'm supposed to write? Intersection. Yes. I could also have A intersection B union C. Open the bracket. A intersection B, A intersection C, and in between we are going to have union. Basically, we are opening the bracket. Yes. Sixth. So we are done with commutative, we are done with associative, we are done with distributive, the basic properties of algebra. Now we are going to talk about some special properties that only sets have. See, right? First, if I find A complement, that is what? Universal set minus A. And I find the complement again, simultaneously twice, what will I get? Hey, back again. If the universal set is 1, 2, 3, and my set A has 1, comma 2. So in the complement, what will I have? 3. Again, I find the complement of the 3. What will I get? 1, 2. That is the set A itself. So if I find simultaneous complement of a set again, it gives you the same set back. Understood? So this will be clear. What will be the complement of null set? Universal. From the complement is what? You subtract from the universal set, null set. That means what are you subtracting? What are you removing? Nothing. So entire set remains. Agree? Whenever in doubt, take an example. Always. What is normally? लिखते कैसे है तो कुछ यूनिवर्सल तो हाँ उसी के लिए पूछो राइट नॉर्मली इट्स ओके व्हाट इज द कॉम्प्लीमेंट ऑफ यूनिवर्सल सेट null set 8. 8. What will be A union A? A. A intersection A. Again, the set itself A. A union A complement. This is A, and outside is A complement. So union, that means take A as well as take A complement. So what have I got? Entire universal set. What would be A intersection A complement? See, take an example. Universal set 1, 2, 3. Set A is 1, comma 2. What will be A complement? 3. So what is the common part in A and A complement? None. None is null set. How can it be common? See, what is A complement? Something that is not in A. The very definition is contradictory, right? Is it okay? Is it okay?
Yes, ma'am.
Thank you.
Yes, ma'am.
What would be A union universal set? A is 1, 2, universal set is 1, 2, 3. If I combine them, what will I get? The universal set is the largest set. I don't need to add anything to. So I'll get universal set. What would be A intersection universal set? What would be A intersection universal set? Take an
Yeah,
example
ma'am.
and check. Sorry?
Yeah, ma'am.
Yes. Universal set 1, 2, 3. A is 1, 2. What is the common part between them? What 2? A itself. Then we talked about De Morgan's law. What was De Morgan's law? A union B whole complement. What was the law? That open the bracket, give the complement to both of them, and the operation in the center gets reversed. So what should I write? A complement intersection B complement. What about the A intersection B whole complement? Union B complement. So if I'm taking opening the bracket or whether I'm taking the complement common, in both the cases, the operation gets reversed. Clear? Clear, guys?
Yes, yes, ma'am.
Okay. See, now A minus B. This means A and not B. I want A, but I don't want them to be in B. I want only those elements. So A is A. For and, what symbol do we write? And is intersection. Not B is B complement. So A minus B can also be written as A intersection B complement. I want it in A, but I don't want in B. Not B is B complement, something that is not present in B. Clear? Similarly, B minus A will be, I want B, but I don't want A. So I want B and I don't want A. Clear? Clear? What will be none? How will you represent this? Not A and not B. Yes or no? I don't want A as well as I don't want B. I don't want either. Right? So how should I write it as a symbol? I don't want A and I don't want B. So A complement intersection B complement. Agree? How? See. How? This part is none. We know from the diagram. Yes. So now first, what would be A complement? A complement will be everything outside the setting. When I talk about B complement, it will be everything outside the set, right? Now what I want is intersection of these two common part. Something that was not in A and something that was not even in B. So which part is common between the two? This part outside the two circles? Because this moon part was here, but it is not in the other one. This moon part is here, but it is not in the other one. So I can't take them in the common area. It's outside. Understood? Understood? Guys, understood?
Yes, ma'am.
Okay. Now we'll talk about certain proof that. We want to prove that A minus B equal A intersection B complement. Sometimes a similar question can also be asked that shade this area. I'll give you an operation and I want you to shade that part, right? That also can be asked. So whenever we are doing proof that, what we do is we can take example. When we show that it is in this particular example, it holds. That is verification. There's a difference between verification and proof. I say that I'm extremely honest person. And I tell you, see, right now you ask me something, I'll say the truth. This is verification for one instance. But if I want to prove that I'm always honest, it has to be in general. No matter when you ask me, it has to be stated by a universal fact. I don't lie. Agree? Similarly, here, if it would have been a verification, then they would have given me that A is this, B is this, universal set is this. So only for that example, I'll find my LHS value, I'll find my RHS value, and I'll show that, okay, see, this is same. But in case of proof that, what we do is we verify, we do it with the help of a Venn diagram. I'll show you both. What is the difference in proving and what is the difference in verification? Proof. What we will do is we'll draw Venn diagram for each step. We'll draw Venn diagram for each step. Done? So first table. I want to plot A minus B, that is my LHS. So A minus B is this part. Done? Now for my RHS, it is a combination of a few operations. So in my table 2, I'm only marking A. A is this entire circle. In my table 3, I'm marking B complement. B complement is everything outside the circle B. Sorry. Yes. Outside the circle B, I've shaded everything. Now, in the fourth one, A intersection B complement. So what I want is the common area between the second and the third. So if we can see what is common, see in this case, outside region was there. But in second, the outside region was not shaded. So the outside area can't be common between 2 and 3. Yes or no? Okay. Now, what is the common area between second and third? It can't be the outside area. Now, the intersection part is not here, but it is here. Again, I can't take that into common. So the only part that is common is these two regions, right? So we'll shade this part, right? So from table 1 and table 4, we can see that the LHS is same as RHS. From table 1 and 4, we see A minus B is same as A intersection B complete. Understood? Understood?
Yes,
Yes,
ma'am.
So,
ma'am.
same cheese, how can we verify now? Verify that A minus B is same as A intersection B complement. When we are verifying, we take an example. So, let us take universal set to be 1, 2, 3, 4, 5. Don't take a hyphen example. Take a small example always. Set A, take any numbers 1, 2, 3. Set B, I am taking say 3 and 4. Done? So for LHS, it is A minus B. What is the value of A minus B? A minus B. From A, I removed the common elements with B. I got 1 and 2. Right? For RHS, A intersection B complement. A is 1, 2, 3. Intersection. What is the complement of 3, 4? B complement is what? Universal set minus B. So from 1, 2, 3, 4, 5, subtract 3 and 4. What do we get? 1, 2, and 5. What is the common element between the two? That is same as LHS. This is verification. Understood the difference? If we want to prove in general also, in other subchapters also, proof is always a fact. We need to prove in general. I can't take an example. And when we talk about verification, we take an example. Understood? So
Yes,
Yes,
try
ma'am.
to
ma'am.
prove that A union B whole complement is same as A complement intersection B complement. Okay, let's try. First table, A union B. A union B will be the entire two circles. Then A union B complement. That is everything outside the two circles. Yes, this is LHS. Third, we have A complement. Everything outside the circle A. Fourth table, B B complement. Everything outside the circle B. Yes. And then we have their intersection. Fourth, A complement intersection B complement. So in table 3 and 4, what is the common part? Outside the two circles is the only common part that is shaded in both the regions. Yes. So from table 1 and table 4, we see that A union B from table 2, sorry, whole complement is same as A complement intersection B complement. Understood? Done? Now, coming back to again the formulas that we did in our last case. Every formula can be done, even the sums can be done using Venn diagram. But you can't present using Venn diagram. You need to present using formulas, right? So first you can imagine in case you're stuck somewhere, you imagine it in the Venn diagram and then you can formulate your own formulas also. It's okay. What were the formulas we learned? Cardinality of A union B. Cardinality of A plus B minus A intersection B. Then cardinality of A minus B. That is A minus A intersection B. A complement. Universal set's cardinality minus the set A. Done. Majorly is this. Done. Okay. So for two variables, let us first try ML Agarwal sum. Exercise 5.4. Question number 1. Okay. So we are given A, we are given B, we are given intersection. Given A has 20 element, B has 18 element, and the intersection has 5. First thing that we need to find is union. So we can use the first formula. Yes. So cardinality of A plus B minus intersection. So 20 plus 18 minus 5, that is 33. So there are 33 elements in both of them. Yes. Second, cardinality of A minus B. How do we find A minus B? From A, subtract intersection. So 20 minus 5, 15. How do we find B minus C? From B, subtract A minus A intersection B. So B was 18, subtracting 5, we get 30. Yes? Any doubts?
Okay.
Question number 2. See, let's try using Venn diagram. Okay, this is A and this is B. Union is 18. A minus B. What is A minus B? This portion, 5. Then we have B minus A, 3. And it says A union B. What is A union B? Collection of all the elements, all the two sets. That is how much? 18. So if I want that to be 18, then how many elements should be there in the common area? 10. Yes or no? The number of elements in the common area should be 10. See, this portion is A minus B. This portion is B minus A. And this portion, so we know, can we not make our own formula? Number of elements in A union B. How can we write that? I can write them as the sum of all the three. Cardinality of A minus B. Cardinality of A intersection B plus cardinality of B minus C. So this is 18, this is 5, this is intersection, and this is 3. Solve, will get intersection to be 10. So Venn diagram will always come to your rescue if you are very sure about which portion is called what. If you're sure about it, you can always make your own formulas. Clear?
Yes, ma'am.
Done? Question number 3. If A and B are two sets such that same, this is A and this is B. This portion is A minus B. This is B minus A, right? This is 5 and this is 3 elements. And this portion is A intersection B, which has how many elements? 10, right? Any doubts? So
No.
the first one, what is the cardinality of A union B? How should we find this? Sum of all the three? A minus B plus A intersection B plus B minus A. So 5 plus 10 plus 3. That makes it 18. Understood?
Yes, ma'am.
Yes.
Any problem?
No.
No.
Any problem? Then, second, n of A, number of elements in A. So, A is this entire circle. So, if I want A, what will be the answer? 15, right? But I have to write in the form of a formula. What should I write? Cardinality of A minus B, intersection B. Understood? A minus B is the only A part, moon part. A intersection B is the lens part. If you add them, we get the entire circle A, right? So this becomes 5 plus 10, 50. Any doubts? Similarly, we can also do it for n of B. N of B will be very good. So this will be cardinality of A intersection B plus B minus A. That makes it 10 plus 3, 13. Any doubts?
No.
Question number 4. Universal set is 48. A complement union B complement is 36. So in this, if I take complement common, it becomes A intersection B. A intersection B complement is universal set minus A intersection B. This is 48. 36 comes this side. N of A intersection B. Any problem till here? So from here, what will be the intersection value?
12, ma'am.
12. Done? Done?
Yes, ma'am.
Fifth. So again, we have universal set 40. We have A 22. We have A intersection B 8. And we have A union B whole complement 6. So this is universal set minus union. Universal set is 40. 6 comes here. This is A union B 36. For union, we have the formula A plus B minus intersection. Yes. So A is 22, B is missing, intersection is 8.
It's 34.
So 36 minus 22 plus 8. Answer 20. Varsha. Sorry. Done?
Yes, ma'am.
Universal set A and B is given. Universal set is 50. A is 30 and B is 28. Agree? So the first question, what is the greatest value of the union? Right? So union is always a part of the universal set, right? union can be at most equal to the universal set. Yes or no? It cannot go beyond that. Agree? Universal set, union of two set is a subset of universal set. So the number of elements present in the universal set is always smaller than or equal to universal. So number of elements in universal union of two set has to be smaller than and equal to 50. It cannot go beyond 50. The highest number is what? Till the universal set, right? So it cannot go beyond that. So the maximum possibility in this case is what? 50. Agree? Can I reach that? Yes, 30 and 28 is 58. Sometimes what happened is in the set B, there is only 10 elements. A has 30, B has 10. So it cannot go beyond 40 in that case. Then in that case, this won't work. Agree? Since by adding A and B, it has crossed beyond the universal set. So that's why universal set is the upper limit. If set B would have had only 8 or 10 elements, then A and B combined is only 40. That is way less than the universal set. And in union, I cannot take elements outside the A and B. So I cannot go beyond 40. In that case, it would have been a maximum of 4. Here, why didn't I add them 58? I can't have 58 elements. Why? In the universal set itself has 50. Understood? So, greatest possible value is 50. Second, what is the least value? So now we know that universal set is smaller than and equal to 50. Union of two sets, sorry. So A plus B minus intersection is smaller than and equal to 50. A is how much? 30. This is 28. 50 comes here. This is intersection. This is 8. That means I need to have a minimum of 8 intersections. Yes, because if I would have added A and B, I'm getting 58 elements. And the universal set itself has only 50. So those 8 elements are definitely common. I can have more than that also. But to a minimum, I need to have 8 elements common. Agreed? Online agreed?
Yes, ma'am.
Yes, ma'am.
Done? As a homework, try at your home 7, 8, 9, and 10. Yes? In our next class, we'll discuss that and do the sums for 3 sets. Like this.